Here is a video demonstrating how to use Plotly to plot a scatter bubble chart. For data visualization, nowadays scatter plot to show the relationship between two variables may not be good enough, and more scatter plots are depicted in this kind of scatter bubbles diagrams. And here, say for example, you can find an example, right, showing the life expectancy versus GDP per capita of all the countries in the world. But unlike the traditional scatter plot, which simply show the relationship of these two variables, this kind of bubble chart can tell even more relationships with other variables. Say, for example, the color code. Here, the legend shows that the bubbles refers to countries in Africa, and the orange ones are in Asia, etc. So you will find a cluster of bubbles on the left bottom corner, and the green bubbles on the top right, which can tell that besides the GDP effect on life expectancy, the continent would also result in some forms of clustering. And also, by means of the bubble size, which represents the population size, can also tell another dimensions of effect. Simply put, a scatter bubble chart can show the relationships between 3 to 4 different variables. But currently in, say, for example, Excel, it would be very difficult to plot such a bubble chart. So here I am going to show you how to use Plotly, a Python code platform in Colab to show how to plot a bubble chart step by step. So first of all, here the first routine is to install the Plotly version 5 and then import plotly.express SPX. So it may take 1 or 2 seconds to install. Okay, then let's import a data file which can have 3 to 4 variables to be shown in a scatter bubble chart. Say, for example, here I use Google Colab import drive, and then based on these pandas PD reading CSV function, and for my Google Drive, I have already downloaded a life expectancy versus GDP per capita data file in CSV format from our World in Data or website. Let's show you the first 5 rows of the data. Okay, after getting the authorization code, then it shows the first 5 rows of the data set, which include country code. I confined the year to 2015, the life expectancy, probably in year, and then the GDP per capita, and also the total population size and the continent. I'm going to plot the bubble chart, right, between the life expectancy and GDP per capita with the bubble size relating to the total population, and then the color code based on their continent. Okay, let's show a traditional scatter plot first. So I define DF 2015 by means of this data query to plot a figure 2015, which is based on PX. That's the Plotly Express and scatter plot. The scatter plot of this data set, DF 2015 divided above, with the x-axis named GDP per capita and y-axis as life expectancy. Let's show the diagram. So it shows a traditional scatter plot, right, with all the dots on an XY plane, and it allows information to be shown on each dot. But first of all, it shows a nonlinear relationship. So in order to find a linear relationship, right, very often we will convert the horizontal axis to a logarithm scale, see whether it works or not. So it's very simple. I simply add comma log underscore x equal true, then it will convert the figures into a log scale. Yeah, here I showed you, right? The same scatter plot, but by converting the horizontal axis into a log scale, then the scatter plot seems to show a much stronger positive linear relationship between the two. But still, we would like to show the continent effect and the population effect. Here it is. F is in the same, except that we add comma size equal the a variable you would like to show the size of the bubbles. Here is total population, and then right you can change these figures to change the size, maximum size of bubbles, and here color can depend on the variables in your data set. Here is continent. Let's try. Right, your cursor move to the bubble. Say for example, this orange one, right, seems to be on the very top right-hand corner. It is Japan with the GDP per capita and life expectancy total population being shown here. And so it becomes a much more powerful scalar bubble chart. And of course, right, there are still a lot of improvements. And for more details on Plotly, you can click to this basic chart, which provides you many other charting functions for data visualization. And then for the data sources, you can refer to this Our World in Data file, and then try to practice by yourself.